Welcome. Today we are going to see about mesh analysis problems. Okay, you need to find the currents flowing in the resistance given in the circuit using mesh analysis, and also find the power dissipation across resistors. Okay, first you need to find the currents flowing in the circuit. Then we are going to find the currents that are flowing through 5 ohm resistor, 20 ohm resistor, 10 ohm resistor, and then we are going to find the power dissipation across the 5 ohm resistor, 20 ohm resistor, and also through the 10 ohm resistor. Okay, very easy mesh analysis, very easy. Okay, similarly you need to assume the two currents I1 and I2 flowing in clockwise direction. Okay, same as Kirchhoff's law. Okay, next step one is this is the formula. Okay, you know V is equal to IR, which is nothing but Ohm's law. V is equal to IR. So here you are having two loops. Okay, we are having two loops. So we are having V1 and V2, I1 and I2, and R11, R12, R21, and R22. Okay, uh, we don't know the current I1 and I2, which is the unknown value. Okay, you are going to find the current I1 and I2, which is the unknown value. So we know what is V1, we know what is V2. Okay, here this one is V1 and this one is V2. We know all the resistance values R11, R12, R21, and R22. All the values are given in the circuit itself. So first we need to substitute all the values in the matrices and then use Cramer's rule to solve the equation. That's all, very simple. Okay, how you need to substitute the values, I will explain you one by one. Okay, for V1, what you need to do is you first take the loop 1. Okay, first take the loop 1 and see how the current is flowing. It is flowing from minus terminal of the battery to the positive terminal of the battery. So what will you do is it is nothing but plus 30 volt. Okay, so you directly substitute the plus 30 volt over here. Okay, next I1 current is the unknown value, so leave as it is. Then you need to fill R11 and R12. This thing, this row corresponds to the first loop. Okay, R11 and R12 corresponds to the first loop. Okay, so for R11, what you need to do is the current is flowing through this loop. This is the first loop. So you try to add this two resistance value 5 plus 20, which is nothing but 25. Add this two resistance value and total resistance present in the loop 1. Okay, 5 plus 20, add this two value and put over here. For R12, here loop 1 and loop 2 are present. Okay, for that you need to see this is the 20 ohm resistor which is present in loop 1 as well as in loop 2. Okay, for this what you need to do is see the current value. The current I1 current is flowing from this direction. Okay, whereas I2 current is in the reverse direction. Okay, I1 is in positive direction, sorry, clockwise direction, whereas I2 is in anti-clockwise direction of I1. So you need to put minus 20. Okay, that's all, very simple. Same as Kirchhoff's law, but you are directly putting the values in the matrices. Okay, this is the difference between Kirchhoff's law and mesh analysis. Then for finding the loop 2, we need to find what is V2 value. To find the V2 value, what will you be doing is see the current which is flowing. It is from minus terminal of the battery towards the positive terminal of the battery. So this represents voltage rise. So we will be putting plus 40 volt. I2 is unknown value. Then move to R21 and R22. This is the loop 2, representation of loop 2. Okay, for R21, that is the resistance which is common to loop 2 as well as loop 1. So which resistance is common? This resistance is common. So for this resistance you can see the current I2 is from anti-clockwise direction, whereas the current I1 is from clockwise direction. So we will be substituting minus 20 for R21. And for R22, what you need to do is simply add this to 20 plus 10. What is the value? 30. Just put it over here. That's all. Very easy. The matrices are formed. After forming the matrices, use Cramer's rule. What you need to do? Find the determinant of this matrix 25 minus 20 minus 20 30. Okay, if you find the determinant of the matrix, you will be getting 350. Okay, next, what we are going to do is find a delta 1. How will you find delta 1? Remove this first column 25 minus 20, remove this first column and use 30 40 in here. In the place of 25 you need to put 30, and this place of minus 20 you have to put 40, 30 and 40, and then put minus 20 and 30 as it is and find the determinant value. Next, for delta 2, remove this two values minus 20 and 30, remove these two values and substitute 30 for minus 20 and 40 for plus 30. And find the determinant value, which is nothing but 1600. Okay, after finding the determinant values, what we are going to do is we can find the I1 current directly. How will you find the I1 current? Which is nothing but delta 1 divided by delta value. Okay, delta 1 you know 1700, delta value is 350. Just divide the two values, you will get 4.8571, okay, amperes, which is the current flowing through the I1. And for I2, what you need to do is delta 2 divided by delta, which is nothing but 1600 divided by 350, which will give you 4.5714 amperes. Okay, these are all simple mathematics you have already studied in your plus 2. Okay, how will you find I3 current which is flowing through the 20 ohm resistor? It is nothing but the current, and you find the current. Okay, next we are going to see the current flowing through the 5 ohm resistor is I1, which is nothing but 4.8571, and the current flowing through the 10 ohm resistor is I2, which is 4.5714 amperes, and the current flowing through the 20 ohm resistor is I3, which is I1 minus I2. Subtract these two values, you will get 0.2857 amperes. Okay, now you have completed the question. What is the current flowing through the resistance given in the circuit using mesh analysis? This part is over. Okay, you have find the current flowing through the resistances given in the circuit using mesh analysis. The next part in the question is find the power dissipation across the resistor. How will you find the power dissipation? First, to find the power across this 5 ohm resistor, you know the formula P is equal to V into I. Okay, you know P is equal to V into I. Okay, next what you know is V is equal to I into R. Okay, so substitute I into R over here. Okay, so what you get is P is equal to I square in what you will doing is here is you know the current I1 which is flowing through the 5 ohm resistor, which is nothing but 4.8571 ampere. So substitute the value of current I1 square over here and put the 5 ohms as a resistance over here. So you will be getting 4.8571 whole square into 5, which is 117.957 watts. Okay, for 10 ohm resistor, what is the power? What will you do? You will substitute the I2 value, which is nothing but 4.5714. 4.5714 the whole square into 10. Okay. For I3, that is the 20 ohm resistance power dissipation is I3 whole square into R, which is nothing but 0.2857 whole square into 20, which will be equivalent to 1.632 watts. Okay. This is very easy. Okay, when comparing to Kirchhoff's law, you can complete this sum within a couple of minutes. Okay, you are going to just put the values, substitute all the values in the matrices. After finding the matrices, you are going to use Cramer's rule. After finding the Cramer's rule or after completing the Cramer's rule, you will get all the current values I1, I2 and I3. After getting this current, to find the power dissipation, the only one formula is P is equal to I square R. So substitute all the values in the corresponding places and you will get all the power dissipation across 5 ohm, 10 ohm and 20 ohm resistances. Very easy. Okay. Next, we move to the next question. Okay. Here, the only difference is the battery sign. Okay. What has happened is you have converted the current sign. Current is going from positive terminal of the battery towards the negative terminal of the battery. So what you do is the equation is the same, but here you are having the only difference is in the loop 2. What you'll be doing is the current is from positive terminal of the battery towards the negative terminal of the battery, that is the I2 current. So you will be getting minus 40 volt over here. Other all the matrices are same. Okay. While seeing the loop 1, you see the current is from negative terminal of the battery towards the positive terminal of the battery. So it is plus 30 volt. So for R11, what you need to do is fly plus 20, you get 25 ohm. And R12, here the I1 current is in clockwise, I2 is in anti-clockwise. So you get minus 20. And for the loop 2, you get the battery voltage is reversed, so the current direction is also reversed. It is from positive terminal towards the negative terminal, so there is a fall in potential, so you get minus 40. And here you see the current I2 is in the anti-clockwise direction across the 20 ohm resistor, whereas the current I1 is in clockwise direction. So what you get is minus 20. Okay. For R21, you get minus 20. Okay. R21 represents the second loop and the 1 represents the first loop. Okay. So you need to see the 20 ohm resistance. Okay. Next for R22, so this is the loop 2. So this R22 represent 20 plus 10, which is 30. Okay. What you need to do is find the determinant of this matrix 25 minus 20 minus 20 30, which is 350. Then find the determinant of del 1, okay, which is nothing but 30 minus 40, this one, and minus 20 30, this one. Okay, find a delta 1, which is 100, and find a delta 2, which is 25 minus 20, this one, and 30 minus 40. Okay, so you get this matrix. Okay, so find the delta 2, you get minus 400. Then to find the current I1, what you need to do is delta 1 divided by delta, which is nothing but 0.2857 amperes. Then here x1 represents the current I1. Okay, don't worry, I forgot to change this thing. Okay, which is nothing but I1 and I2. Okay, x1 is I1, x2 is I2. Okay, I2 is 1.1429 amperes. So you can directly find the current's 5 ohm resistance I1 is equal to 0.2857, and through the 10 ohm resistance the value is minus 1.1429 amperes, whereas the current through the 20 ohm resistance, you see the current 20 ohm resistance I1 is in clockwise direction and I2 current is in anti-clockwise direction. Okay, so what you need to do is I1 minus I2 is the current, which is I3, which is flowing in the 20 ohm resistor. So you need to subtract the two values, which is 0.2857 minus of minus 1.1429. So this will become addition. Okay, so add these two values, 1.4826 amperes. So to find the power dissipation, very easy. You know what the only formula is I square R. So to find the power dissipation across the 5 ohm resistance, what you need to do is I1 square into 5 ohm. I1 is nothing but 0.2857 whole square into 5, which is 0.4081 watts. Okay. Then the power dissipation across the 100 ohm resistance is nothing but I2 square into resistance R, which is nothing but 10 ohms, minus 1.1429 whole square into 10. You will be getting 13.062 watts. Then for the power dissipation across this 20 ohm resistance, what we'll be having is I3 square into R, which is nothing but minus 1.4286 whole square into 20, which is 40.818 watts. Okay, very easy. Very simple. You can easily find all the values, substitute everything, find the answer. Immediately you will get 8 marks or 12 marks for the sum. Very easy problem. Okay. Next, for the third equation, uh, same same steps. Okay, the only thing is the matrix is bigger. Okay, for 3 loops you will get a 3 cross 3 matrix. For 2 loops you will get a 2 cross 2 matrix. Okay, here you can see V1, V2, V3 are the three voltages across the 3 loops. Okay, I1, I2, I3 are the 3 currents across the 3 loops. And here R11, R12 and R13 represents the common resistances across the loop R1, whereas R21, R22, R23 represents the resistances across the loop 2. Okay, and here R3. Okay, now you can see R31, R32 and R33 are the resistances across the loop 3. Okay, now what you need to do is you need to substitute all the values. Okay, for V1, what you know, the current across the battery is from minus terminal to the positive terminal. So current I1 is you need to find the current I1. So make as it is. For R11, you need to see this is the loop 1. Okay, R11 represents the loop 1 resistances. So what you need to do is just add these two values. What is the value? 25. Okay, R11 is 25. And R12, you need to see the loop 1 and loop 2, which resistance is common. For loop 1 and loop 2, this resistance 20 ohm is common. So what you get here is minus 20. Okay, here you need for loop 1 you will be adding two resistances, which is 25, and a loop 1 and loop 2 common R12 here you will getting minus 20. And for R13 represents the common between loop 1 and loop 3. Here is loop 1. Okay, and loop 3 is over here. Is there any resistances common? No. Okay, there is no resistances common because loop 1 is here and loop 2 is here, loop 3 is here. Okay, loop 3 is not associated with the loop 1. Okay, before in between these two loops there is a loop called a loop 2. Okay, so what will be having here is R13 is 0. Okay, I will show you. Here V1 is 30, I1 need to find. Here you need to add which is 25 and R12 is minus 20. You see loop 3, that is R13 because R1 loop 1 is here, loop 3 is over here. There is no association between loop 1 and loop 3. So you directly put 0 over here. Okay, for loop 2, very interesting. You can see there is no battery sign. Okay, so you put 0. Here I2 is the current flowing, leave it is. Then for loop 2 1, that is the association between the loop 2 and the loop 1 current. Here loop 2 is here and the loop 1 is here. So the common thing here is 20. So you get minus 20. Okay, and for loop 2, what you need to do, R22, what you need to do is 20 plus 10 plus 15. Add all the resistances across the loop 2. 20 plus 10 plus 15, which is nothing but 45. Okay. For R23, the common between a loop 2 and a loop 3. What is the common resistances? Which is nothing but 15 ohm. So what you need to make is minus 15. Okay, very easy. Put minus 15. Okay, so loop 1 is minus 20. The R22 is 45 and R23 is minus 15. Okay, next for loop 3, what you need to see is the current direction V3. So for V3, you see the current I3 is from negative terminal of the battery towards the positive terminal of the battery. So there is a rise in potential. So you will be getting plus 40 volt. Okay, so put plus 40 volt over here and then put I3 over here. And for here, you need to see R31. Okay, you see loop 3 is over here and loop 1 is over here. So there is no common thing between loop 3 and loop 1 because loop 2 is present in between loop 1 and loop 3. So you will get R31 value as 0. Similarly, you will get R13 value as 0. Okay. So next you need to find R32. Loop 3 is here, loop 2 is here. So the common thing is 15 ohms. So what you need to put is minus 15 over here. Okay, next what you are going to see is R33, which is nothing but loop 3. Here is the loop 3. So what you need to do is just add the two values. 15 plus 25 will give 40. Okay, very interestingly, we have find all the values of the matrices. Now the same thing you need to do. First, find the delta value, that is the determinant value for solving using Cramer's rule. So the determinant of this matrix 25, 20, 0, minus 20, 45, minus 15, 0, minus 15, 40 is 233. Sorry, what is this? 23,375. Okay. Then what you need to do is find the determinant value of delta 1. Okay. To find delta 1, what you need to do is remove this column 25 minus 20 0 and substitute 30 0 40 in the column number 1. Okay. 30 0 40, then minus 20 45 minus 15, then 0 minus 15 40, and find the determinant value for delta 1, which is nothing but 59,250. Then find the determinant value for delta 2. For delta 2, what you need to do is remove the second column and substitute 30 0 40 in respective of minus 20 45 minus 15. That is, the delta 2 will be like this, which is 25 30 0 minus 20 0 minus 15 0 40 40. So determinant of delta 2 will be 39,000. Okay, next you need to find the determinant of delta 3, which is nothing but remove the third column 0 minus 15 40 and substitute 30 0 and 40. So what you get here is 25 minus 20 30 minus 20 45 0 and 0 minus 15 40. Okay, so find the determinant of delta 3, which is nothing but 38,000. Okay, then you can find the current I1 by dividing delta 1 divided by delta, which is nothing but 2.5348 amperes. Okay, then you need to find current I2 by delta 2 divided by delta, which is nothing but 1.6684 amperes. For I3, what you need to do? Divide delta 3 divided by delta, which will give you 1.6257 amperes. Okay. Next, what we are going to do is the currents. To write the currents flowing through the 5 ohm resistor is I1, which is nothing but 2.5348 amperes. Okay, then the current flowing through the 10 ohm resistor is 1.6684 amperes, and the current flowing through the 25 ohm resistor is I3, which is nothing but 1.6257 amperes. Then what you need to do is find the current flowing through the 20 ohm resistance. To find the current, you see the current I1 is flowing in the clockwise direction, okay, like this, whereas the current I2 is flowing in the anti-clockwise direction. So what you need to put is I1 minus I2, which is nothing but 0.8664 amperes. And similarly, you for 15 ohm resistance, this the current will be I2 minus I3, which will be 0.0427 amperes. Okay, very interesting. All these things are same as Kirchhoff's law. Okay, the only thing is you need to solve using matrix. So the power dissipation very easy to find. The only formula is I square R. You know all the currents I1, I2, I3, I4 and I5. So what you need to do is the power dissipation across the 5 ohm resistor is I1 square into 5 ohm. Okay, I1 square is 2.5348 square into 5, which is nothing but 32.1261 watts. Whereas the power dissipation across 10 ohm is I2 square into R. You know the I2 value 1.6684 in whole square into 10. Okay, so you get 27.8356 watts, and power across 25 ohms is I3 square into R. Similarly, the other powers are P 20 ohm and P 15 ohms. So the formula is same. Okay, substitute the values and find these things.